Swayam Prabha. Digital India. Educated India.
Hello learners, I am Dr. Rekha Sharma, Professor retired from UGC Human Resource Development Center, Rashtrasant Tukaroji Maharaj Nagpur University, Nagpur. In this video we shall study malting. Now objectives of this video are, after studying this video, the learners will be able to describe the steps of processing of malting and will be able to enumerate the uses of malting. Malting is a controlled germination process which activates the enzyme of the resting grain, resulting in the conversion of cereal starch to fermentable sugars and partial hydrolysis of cereal proteins and other macromolecules. Barley is the grain most generally used in the production of malt, which finds industrial uses in breweries and distilleries. In commerce, the term malt is applied to barley malt. Small quantities of other cereals are used for malting and they are designated as wheat malt, ragi malt, jowar malt, etc. Now let us study the malting process. It starts with pre-cleaning, cleaning, grading and storage. Then the second step is steeping, then germination, then kilning, then separation of culms. Now let us study these in detail. This is the whole process of malting, right from cleaning to the malt germ. We will be discussing these steps one by one. Now let us start. First is pre-cleaning, cleaning, grading and storage. After harvesting, barley is prepared for storage during its period of dormancy before conversion to malt under conditions minimizing the risk of infestation from insects, fungal attack, etc. To achieve this, it is necessary to dry the wet or green grain from the fields for long-term storage down to a moisture content of 12%. Grain with moisture levels between 10% and 12% can be stored for long periods, although initial drying down to 15% to 16% could be acceptable, providing that the grain is stored for short periods and preferably cooled. Cleaning has to remove impurities of about the same size as barley, as wheat seeds of grains of other cereals as well as broken grains or undersized grains. Now steeping. During steeping, barley takes up water and swells by 1/3. Respiration increases slowly at first and then more rapidly, causing the grain in steep to accumulate carbon dioxide and heat up. This is aggravated by the action of microorganisms associated with the barley. The steeping stage consists of alternating periods when the grain is immersed in water, referred to as the underwater periods, and periods with the water drained from the grain, referred to as the air rest periods. This combination is required to promote and maintain the efficiency of the germination. It is necessary to increase the water content of barley to 42% to 46% during the steeping process in a typical temperature range from 15 to 20 degrees centigrade. When barley absorbs water, the embryo becomes active and uses the oxygen dissolved in the steeping water for respiratory purposes. During the first period underwater, the dissolved oxygen in the water is rapidly absorbed by the organic material and microflora in the grain. Steeping is of considerable value in removing dirt from the grain. The film of dust and many of microorganisms adhering to the grain are washed away by the steep water. Steep water leaches husk components that may impede germination and any musty smell that may be associated with the barley, and possibly some that prevent proper flocculation of yeast. The germination. The germination process is characterized by the growth of the embryo of the grain, manifested by the rootlets, growth and increase in length of the shoot, that is acrospire. A large increase in the quantities of some of the hydrolytic enzymes present in the grain is one of the essential changes of modification. The alterations of the starchy endosperm begins due to the partial degradation of reserve substances, that is cell walls, gums, proteins and starches. The hydrolytic enzymes that catalyze modification are derived mainly from scutellum and aileron layer. In the initial stages of germination, the scutellum releases many hydrolytic enzymes that begin to degrade the cell walls of the crushed cell layer, the walls, protein and starch granules of the endosperm. In addition to enzymes, the scutellum releases gibberellins, which stimulate the production and release of numerous hydrolytic enzymes by the aileron layer. Alpha amylase is absent from the hydrated aileron, and its de novo synthesis and release are independently triggered by the arrival of the hormone. In malt, approximately 85% of this enzyme originates from the aileron layer and 15% from the scutellum layer. Beta amylase, which exists in the original barley in an inactive form in the starchy endosperm, is liberated and the degradation of the component proceeds. Proteases and carboxypeptidases accumulate in the starchy endosperm during germination. Beta-glucan solubilase is a carboxypeptidase that converts the insoluble cell wall protein matrix to high molecular weight soluble. But viscous beta-glucans, which can create problems during wort separation and beer filtration, are broken down further to low molecular weight glucans and glucose by the endo-beta glucanases and beta glucosidases. These enzymes develop slowly in the malting process and are slightly sensitive to gibberellic acid. Gibberellic acid is an example of germination regulator, which, like potassium bromate, can be added to the grain to greatly accelerate the modification rate. At this stage, the material is called green malt. Now, kilning. Kilning has the characteristics of a typical industrial drying process occurring in two distinct stages. First, moisture is removed from the green malt, reducing it from approximately 44% to 12%. This phase of drying is rapid and is referred to as the free drying or withering phase. The second phase of drying, in which the malt is dried from 12 to 4%, occurs in a much slower process, which is commonly referred to as the falling rate phase. At the end of drying process, the kiln temperatures may be raised for 1 or 2 hours in the curing stage, followed by a cooling period to achieve a temperature suitable for discharge and storage. Kilning dries the malt, preventing further growth and modification, also removes undesirable flavors, partially or wholly destroys some hydrolytic and other enzymes, and develop flavor and color in the final product. Moreover, malt is kilned to produce a friable, readily milled, stable product that may be stored for long periods and from which roots may easily be removed. Now, separation of culms. When kilning is complete, the heat is switched off and the grain is allowed to cool before it is stripped from the kiln in a stream of air at ambient temperatures. On its way to steel or concrete hopper-bottomed storage silos, the malt is dredged to remove dried rootlets or culms, which are extremely hygroscopic and must be stored out of contact with the air. They have a much lower economic value than the malt and are used for feeding cattle. Approximately 3 to 5% of the original barley is recovered as culms in the traditional malting processes. Now, uses of malt. 96% of the malt produced in the world is used as the main raw material along with water to make beer. Malt is extremely important in Scotland for whisky production, representing approximately 3% of the world's malt use. The rest is used as a very important ingredient in the food industry as natural flavoring, breakfast cereals, malted milk drinks or malt vinegar. Malted ragi flour can be used in the preparation of weaning food, infant food, geriatric food, medical foods and also as milk-based as well as alcoholic beverage formulations. It can be used as amylase-rich food ARF to reduce the dietary bulk of energy food and such other supplementary foods. Byproducts like seed coat and rootlets can be utilized in cattle and poultry feed formulations. The addition of amylase-rich flours ARF decreases the viscosity of the porridge and thus can help to make it energy dense. Studies showed that energy dense porridge liquefied with ARF was well accepted by malnourished young children recovering from diarrhea and dysentery, and that the mixture with ARF delivered a higher amount of energy. So, let us summarize. Malting is a controlled germination process which activates the enzymes of the resting grain, resulting in the conversion of cereal starch to fermentable sugars, partial hydrolysis of cereal proteins and other macromolecules. The malting operation starts with the drying of the grain in kiln so that the moisture content of the grain is between 10% to 14%. After drying and cleaning, the grain is stored for at least 3 weeks before malting. For malting, the stored grain is steeped in water for some 50 to 70 hours, after which time the surplus water is drained off from the grain, which is then spread on the floor for 7 to 8 days, where germination takes place. The grain malt is then kiln dried to arrest enzymatic activity. without destroying the enzyme. The dried and cleaned product is malt. These are the references. With this, we have come to an end of the lecture on malting. Thank you.